Thank you. Yeah, we'll start with Turing machine. What is this Turing machine? Why we require this Turing machine? What is the disadvantage of PDA? See, PDA has some memory and that too a small amount of memory, not very large amount of memory, and all the problems cannot be solved using PDA. Okay, so if I want to add two numbers or if I want to multiply two numbers, that cannot be done in PDA. Okay, so what is this Turing machine? Turing machine is a very powerful computing machine. Okay, it is similar to your computer. Any problem that can be solved, that is that can be computed, can be done using Turing machine. Okay, so uh, here I'm not talking about like speed, efficiency and all. I'm only talking about the possibility of computing. Okay, so Turing machine can compute any problem which is computable by computers. That is, any problem that can be solved by computer can be computed using Turing machine. Okay, for example, sorting. Sorting can be done by computer. So yes, sorting can be done even using Turing machine. Searching can be done using computer. Yes, searching can be done using Turing machine. Okay, again I repeat, the efficiency is different, but it can be done by Turing machine. Hence, it is known as very powerful machine. Any problem can be computable can be done using Turing machine. Okay, so what is this Turing machine? We'll just see the definition first. A Turing machine is an accepting device which accepts the language. Which language does it accept, students? I hope you remember this, right? Chomsky hierarchy, type 0, type 1, type 2, and type 3. Which type of grammar does Turing machine recognize? Which type of Turing machine which type of grammar does Turing machine recognize? Unrestricted grammar. Actually saying that Turing machine can recognize any grammar, type 3, type 2, type 1, type 0. That is regular grammar, context free grammar, context sensitive grammar, unrestricted grammar. Okay, the grammar generated by or the language generated by unrestricted grammar is only recognized by Turing machine. The other machine cannot recognize unrestricted grammar or recursive grammar. Okay, the recursive language. So a Turing machine is a mathematical model which consists of an infinite length tape divided into cells on which input is given. I'll just come to this in my next slide. It consists of head which reads the input tape. A state register stores the state. After reading an input symbol, it is replaced with another symbol. Its internal state is changed. Okay, I'll directly move on to my next slide. This is your Turing machine. Students, this is your input tape, okay, which can be, increased infinitely on both the sides. Okay, if you remember PDA uses stack, right? And stack has only one opening, right? Or I can say it can be increased in only one direction, right? You can put the input one by one from one opening or from one side, and you are deleting from the same side, so it is your last in first out, right? Here you have a tape which can be increased in both the direction infinitely. infinitely. Okay, and it has a head which can move in any direction, that is left as well as right. The head can move in both the direction. And what is the operation of the head? It can read as well as write on the tape. Okay, with this small introduction to Turing machine, we'll move on to the formal definition of Turing machine. Okay, coming to formal definition, it is same as your PDA, right? Q is our set of state, summation is input, Q0 is the start state, F is the final state. Here B represents how you are representing blank. Okay, how you are representing blank symbol. You may write B and a slash, small b and a slash, even that represents a blank. We have seen in our PDA, right? You can take capital B also to represent the blank symbol. Okay, then coming to this tau. Tau in PDA, what does it represent, students? Do you remember what tau represents in PDA? What tau represents in PDA? Do you remember? Quickly. Yes. Preeti and Saurabh says push down symbols, stack symbols, right? So tau represents a stack symbol in your PDA. Okay, so here we don't have stack. Instead of stack, what we have? We have tape. So what tau represents here? It represents the tape alphabet or tape symbol. Okay, and then finally we have delta. How to represent delta? We'll see with the example. Okay, so we should have the state. Okay, and then the input, which gives you state. What symbol are you representing for the input? That symbol यहाँ पे summation आना चाहिए. Okay, what is that? State mapped with input gives you next state. The symbol what you are representing on the tape, and after doing this operation, where your head is moving, whether it is moving left or right, or whether it is not moving, no operation, whether it is moving left, whether it is moving right, or there is no operation. So these are your formal definition, with 7 tuples. Okay, with this we'll move on to our next, that is, we'll start with the example. The first example that we will look into is design Turing machine for 0 raised to n, 1 raised to n. We have already done using this PDA. Okay, we'll see how to do this using Turing machine and how to represent it using Turing machine. Okay, so first we'll understand the problem. So this is my tape. Okay, so this is my input. I'll just take down the example. Okay, this is how the input is stored. All these, we assume that they are blank. Okay, so now we always start from here, right? The first element. Okay, we'll start. As we know, the Turing machine can read any element from the given input Okay, and it can move right, left. Okay, so we'll make use of that and try to solve the problem. It is 0 raised to n, 1 raised to n. Matlab equal number of zeros followed by equal number of ones, right? So we read this 0. So what we'll do? We'll check for 1. Okay, is 0 का 1 कहाँ पे है? So for that what we have to do? We have to move right, है ना? So we'll just move, we'll check, ये नहीं है, ये 1 नहीं है, ये 1 नहीं है. So this is 1. Okay, इसका equivalent मिल गया. Fine. So we'll come back again and see. अच्छा ये 0 है. 0 इस 0 का will check which is its equivalent 1. तो ये वाला है. Then we'll see, we'll again come left है ना, and check और एक 0 है. फिर we'll go forward and check ये 1 है, इसका 1. Okay, then we'll come back. ये 0 है, ये 1 है. Okay, so all are done. So it is equal number of zeros and ones. So how we'll do this in Turing machine? Again, I'm taking the example, then we'll move on to actual representation. Okay. Okay. So what we'll do, I have taken here 3 A's followed by uh, students, just a second. Okay. Students, I have taken here 3 zeros followed by 3 ones. Okay. What we'll do in Turing machine, we'll start from the first one. Okay. We'll start from the first one. Okay, so as we have done in our push down automata, that we represent different elements, right? Sorry, different symbols, right? Even we'll do that. तो मैंने एक zero read किया. What we'll do? We will make it x. Okay, and we'll move forward till I get a 1. We'll move right. Okay, forward मतलब right है ना? We'll move right till we get a 1. If we get a 1, what we'll do, we'll make this 1 and come back. Come back matlab we are moving left. We'll move left till we get a x. We move left till we get a x. When we get a x, इसका मतलब मेरा पहले वाला 0 हो गया है, right? So till we get a x, we'll just move left. After we get a x, we'll just move right in search of next 0. Okay, we got a 0, make it x and move forward. That is move right till you get 1. 0 mila on my way. I'll just bypass it. I got a y. I'll just bypass it. Now I got a 1. What should we do for this? Make it 1. ओके तो मतलब इस x का ये y हो गया. अगेन मूव लेफ्ट. आई गॉट अ y. जस्ट मूव. आई गॉट अ 0. वेयर शुड आई स्टॉप? आई शुड स्टॉप एट x. I got a x. So move right in search of next pair. So matlab next 0. I got a 0. Right? Make it x and move right till you get a 1. 1 मिला, इसको y करो and move left again till you get a x. Why we are moving left again till we get a x when we have completed all zeros and ones? Because the machine doesn't know कि सारे zeros हो गए हैं, सारे ones हो गए हैं. It has to check it, right? So just move left till you get a x. Okay, and move right in search of 0. Move right in search of 0. लेकिन आपको 0 नहीं मिला, आपको y मिल गया. इसका मतलब नंबर ऑफ जीरोस खत्म, राइट? यू गॉट अ y आफ्टर soon after x, मतलब नंबर ऑफ जीरोस खत्म. So what should we do now? We have to move right and we have to check कि सारे y ही है ना, कुछ और तो नहीं, यहाँ पे 0 या 1 तो नहीं है ना. We have to check this. Okay, we have to just see that everything is y and it is reaching blank. If it reaches blank, then it is right. That is, number of zeros are equal to number of ones. Is the example clear, students? Is the example clear, everyone? Any doubt in the example? Okay, so we'll see how to represent this. Fine. I hope everyone is clear with the example. I hope everyone is clear with the example, students. I don't know why you people are not answering. Okay, I am again writing this because I want to represent using Turing machine. That is how to represent the same example using Turing machine. Okay, I'll start with the, what is that? Transition diagram. I'll start with transition diagram. Okay, start with the start state Q0. Fine. In the start state, what we are doing? We are reading 0. 0 को हमें क्या करना है? We have to convert it to x and move right. When I get a 0, I should get a 0, right? I cannot get a 1. I should get a 0, make it x, right? And we are making only 10x. So just make first 0x and move right. Okay, तो वो हमें यहाँ पे represent करना है. How to represent that? If I get a 0, make it x and move right. Is the representation clear? If I read a 0, make it X and move right. This is the input. This is the uh, changed alphabet or symbol, and this is the movement of the head. What we are doing, whether we are moving right, whether we are moving left, or we are not moving. अगर right move कर रहे हैं तो R, left move कर रहे हैं तो L, and if we have no movement then N. Okay, that is halt. Fine. Is this representation clear? These three elements, how it is written. The first is one. The first one is input. The second one is what you have changed, and the third one is the direction of the head. Okay, तो ये 0 हो गया, हमने x कर दिया, and we are moving right. तो अभी what we are searching for? We are searching for 1, and we are moving right. On my way, I can get any number of zeros, and any number of zeros should be kept as it is, right? So what we'll do, we'll make a self loop for that. Any number of zeros है ना, so उसके लिए we'll have self loop. अगर एक ही होता तो we would not give a self loop. ठीक है, any number of zeros मतलब I can have 10 zeros here, right? 11 zeros followed by 11 ones. तो first zero को मैंने x किया, उसके बाद I can read 10 zeros, उसके बाद मुझे 1 आएगा. All those 10 zeros should be kept as it is, right? इसके लिए हमें क्या लिखना है यहाँ पे? I'm reading a 0, keep it as it is and just move right. Okay, after that, when after this, so we are just moving right. When we will stop? We'll stop when we have encountered a 1, and we'll convert that to y. है ना? So that has to be represented now. Okay, so what we'll have? What we'll have here? If you read a 1, convert it to y and move. Where we are moving after making this into y, where we are moving, whether we are moving right, left, or no? Yes, right, it is left. We are moving left. After making this y, we are moving left. ठीक है, ये y हो गया, यहाँ तक 1 मिला, उसको y किया and move left. ठीक है, कहाँ तक हम मूव कर रहे हैं? Where we have to stop? Till we get a x. Very good. Till we get a x, and we get only 1 x, right? We get only 1 x, and after that, I'm explaining you why I'm connecting it here. See here, students. Once we move left, okay, in search of x. x मिला मुझे, उसके बाद मैं right move करूंगी. Okay, and after moving right, I have 0, and this repeats. ये जो हमने अभी किया x and y, this repeats again, है ना? So since we have the same process, we just connect it back here. Okay, so this has to be written. What I have to write here? If I get a x, keep it as it is and move right. Okay, Tabish, it is not 1. When we move left, we get 0, right? Any number of zeros, and we move till we get a x. We move left till we get x. Okay, fine. ये हो गया अपना एक्चुअल वाला प्रोसेस, लेकिन बीच में थोड़े बहुत प्रोसेस है जो हमने छोड़ दिया है. विल सी दैट. नाउ x मिला, राइट लिया, आई गॉट अ जीरो. इस जीरो को x किया, फाइन, इस जीरो को x किया, एंड आई एम मूविंग राइट. ओके, इस जीरो को x किया एंड आई एम मूविंग राइट. नेक्स्ट आई केम टू Q1. Q1 में मुझे जीरो मिला, आई kept it as it is and I'm moving right. I may get this y also, है ना? I may get this y also. Even this y has to be kept as it is, so I have to write even that here. If we get any y, keep that y as it is and move right. Did you get this, students, why I have written this? See, when I am searching for 1, right, इस zero को x किया and we are moving right. So what all the elements we can get in our way? I may get 0, I may get y. We should keep it as it is and move right till we get 1. So that also has to be mentioned here. Okay, so now I got a 1, make it y, make this y and move left. Okay, I'm moving left now. I'm moving left. ये y आ गया यहाँ पे, तो उसको वैसा ही रखना है. So y, keep that y as it is and move left. We are moving left in search of x. ये y मिला, keep it as it is. 0 मिला, उसको भी वैसे ही रखना है, right? And move left till we get a x. Till we get a x. तो ये y किया, लेफ्ट गए, till we get a x. तो मुझे यहाँ पे x मिला. Okay, and move right again in search of 0. तो ये 0 मुझे मिला, उसको x करना है and move right करना है. Okay, I'm moving right. I got a y, y को वही रखना है and move right. Okay, ठीक है, y को वही रखना है, move right. Okay, y again, keep it as it is and move right. I got a 1. 1 को y करो and move left. Okay, ठीक है, we are moving left. I got a y. ठीक है, keep it as it is and move left. और एक y मिला, keep it as it is and move left till you get a x. x मिला, ठीक है, यहाँ पे x मिला मुझे, है ना? And I am moving right. अभी मुझे y मिला है, so we haven't written for that, right? We have to write for that now. अभी y मिला, Q3. We got a y, keep it as it is and move left or right. What do I have to do? After x, when I moved right, I got a y. When we did this and move left, I got a x. I move right, I directly get a y instead of 0, क्योंकि number of zeros खत्म हो गया है. Now when I get this y, what should I do? Keep it as it is and move? Yes, I have to move right. Correct? I have to move right. Yes, yes, and Preeti. Good. We are moving right. Okay. Not only this y, we have to bypass all these y's, right? We have to just read this and check whether it is only y. Keep it as it is and move right till we get a blank. ठीक है? तो ये करना है हमें. So what we'll do? Sorry. Okay, so what we have to do? All Y's, keep it as it is and move right. Okay, this we have to continue till we get a blank. If we get a blank, keep that blank as it is and no operation. Or you can write n, or you can write you write n here. Okay, and here you'll have the accepting state QF, and this is your final state when you get a blank. Students, let me know any doubt in this. If you have even a small doubt, let me know, because uh, from next example we'll go a bit faster. If you have any little doubt, small doubt here, let me know, I can explain it again. From the next example, we'll just look at the logic and we'll move forward quickly. Do you have any doubt, students, in this example? Any doubt here in the logic or in this transition diagram? Students, any doubt? Okay, Yashasri has no doubt. Okay, fine. Everyone clear? Everyone, students, please let me know if you have any doubt in this. Okay, you have to take a bit longer example. How did it count equal number of 1 and 0? Preeti, can you elaborate your question? I didn't understand your question. Preeti asks me, how did it count equal number of 1 and 0? I did not get your question. See here, I think what you're asking is whether how did we get that it is equal number of zeros and ones, right? Right? See, we are not counting it. 3 equal to 3. ऐसे नहीं कर रहे हम. Any number, right? Any number, we are not counting whether it is 1, 2, 3. Any number, but it should be equal, right? So ये देखो, हमने ये इसको x किया, right गए, इसका equivalent को y किया हमने, right? Then again we came back, इस 0 को x किया, इसका equivalent 1 को हमने y किया. Again we came left, इस 0 को x किया, इसका equivalent हमने y किया. And after we have no zeros, we saw that there is no ones here also. It is directly a blank. I hope I'm making you understand. You got the point? You can unmute yourself and clear your doubt, Preeti. Did you get this? What is your doubt? Let me know. What if the number of zeros are greater? Yes, very good. Fine. हम देखते हैं वो एग्जाम्पल भी देखे हम यहाँ पे. ठीक है, मुझे यहाँ पे 0 है ना? तो कहाँ पे है वो क्यू? यहाँ पे हम आए. I got a 0, right? I'll take another example with smaller one. Okay, अगर मेरे पास 2 0 है, okay, and I have one single one and a blank. ठीक है, this was our next example actually. We'll do it here. तो इस 0 मिला, मैंने x किया, right? We move right till we get 1. I got a 1, make it y and move left till you get a x. x के बाद मुझे 0 मिला, right? So make it x and move right and move right. What you got? You got y. Sorry, you got y. Keep that y as it is and move right. Okay, and you got a blank here. You did not get 1. You got a blank. You neither got 0 nor y and 1. You just got blank. So there is no accepting state here. So it rejects. It is not accepted. Is this clear? There is no 1 here, right? So it will halt here in non-accepting state. So it rejects. It is not 0 raised to n, 1 raised to n. Got it? Okay, good. Any other doubt, students? Any other doubt, anyone? Any other doubt, students? Let me know if you have any single small doubt, students. Please make it clear. I can explain it a number of times. Students, any other students, do you have any doubt? Got this? Everyone got this? Okay. This is 10 marks question, and sure you'll have a 10 marks question from Turing machine. That is your theory part. And coming to your MCQs, you may get again 3 to 4 questions on Turing machine. Okay, students, is this clear? As I said, in our next example, I'll go a bit faster. Whatever time I want to spend, I'll be spending only on this example. What are the steps required? I'll come to that. Is the example clear? Steps, I'll come to that. I'll come after this, I'll come to that. Is the example clear? Is the logic clear? Is the what is that transition diagram clear, everyone? If this is clear, then we'll move on to how to write it. Okay, so this was our example, right? So first you have to write the formal definition. What is the formal definition? You have to write this. Sorry. Okay, you have to give what are all this, okay. So if you see what is our q is q0, q1, q2, q3 and qf, that we have written here: q0, q1, q2, q3, qf. Okay, and tau, this is tau. Okay, what is tau? Our input symbols, whatever, sorry, input tape symbols, right? That is tape symbols. Whatever we have on the tape, that all should be included. पहले तो 0 1 था, फिर x and y किया हमने उसको, फिर blank भी है. All those have to be included in this. 0 1 x y and b. Okay, we know in what is the input 0 and 1. We have taken qf as the final state, right? And then initial state we have taken q0. यहाँ पे mention हो गया है. You can write q0 is equal to q0, and for blank we have taken b itself. If you see here, we have taken capital B for blank representation. Okay, this is your step number 1. Fine. Next, what is step 2? You have to write the logic. Whatever logic we have used here. What logic we have used? 0 mila, x kiya, move right till we get a 1, make it y, move left till you get a x. And then repeat the steps till there are no more zeros and ones. So वही हमने यहाँ पे लिखा है. You can write it in your own words. There is no like proper statement like ये ऐसा ही लिखना है. Okay, this is what I have written. You can write it according to your convenience, your language. Okay, read a 0, change it to x, move right till you get a 1, change it to y, move left till you get x, and then move right in search of 0. Repeat this till you have no more zeros and ones. Okay, this is the logic. Step 1, define all the tuples. Step 2, write the logic. Step 3 and 4 can be interchanged. अब पहले स्टेप 4 ट्रांजिशन डायग्राम लिख के फिर स्टेट डायग्राम लिख सकते हैं. ओके, हाउ टू रिप्रेजेंट the state table after drawing the transition diagram. See, the representation यहाँ पर तो सेम है, Q0, Q1, Q2, Q3, that is all your states. यहाँ पे Q3 लिया है instead of final state QF. Okay, so Q0 on 0, Q0 on 0 is going to Q1, Q0 on 0, Q0 on 0 is going to Q1, and we are making it X and moving it right. We are making it X and moving it right. We are making it X and moving it right. Okay, ट्रांजिशन डायग्राम में यहाँ पे इनपुट होगा फर्स्ट एलिमेंट. स्टेट टेबल में फर्स्ट एलिमेंट वुड बी द नेक्स्ट स्टेट. दैट इज द ओनली चेंज. ओके, Q0 0 में आप क्या लिखोगे? When you read a input 0, what is the next state? What you are going to do with this 0, and what is the movement of the head? That is the sequence how you will be writing. The same thing has been converted. See here, Q0 on 0 is going to Q1. This 0 will be changed to X and move right. Q0 on 0 is moving to Q1. This 0 is changed to X and move right. Okay, this is what is filled here. Any doubt in this, students? Any doubt in this? Okay, and finally Q3, that is your QF. We have taken QF here. QF, then sorry, Q3 ही था ना, क्या था यहाँ पे? Q0, Q1, Q2 and Q3, right? Sorry, Q3 on reading blank, keep it as it is and no operation. Okay, the same thing, Q3 on blank goes to QF. Okay, blank and no operation. You can write this or you can say halt. Matlab, it has reached the final state. You can just write halt or you can write this. Both this or this, दोनों मत लिखो. Okay, this is just representation कैसे आप लोग लिख सकते हो. You write QF, BN or just halt. मतलब खत्म. Is this clear, students? Is step 3 and 4 clear? Step 3 and 4 clear? Okay, and lastly the example. Okay, take simple example and you have to show each step. जो हमने यहाँ पे किया ना, ये पूरा step आपको हर एक बार दिखाना पड़ेगा. As I have done here. See, 0 0 1 1. तो पहले को X किया. Okay, see here. Q0 0, Q1 XR. हमने 0 रीड किया Q0 में. Go to Q1, right? Make it X and move right. ओके, इतना पूरा स्टेटमेंट में लिखने की जरूरत नहीं है. यू कैन जस्ट राइट दिस Q0, 0 इज इक्वल टू Q1 XR. यू कैन राइट दिस इवन साइड में यहाँ पे. ओके, देन X, इस 0 को X किया, राइट? 0 1 1. तो इस 0 के साथ क्या किया? जस्ट कीप इट एज इट इज एंड मूव राइट. ओके, देन ये 1 मिला, इसको क्या किया? Q1 में 1 मिला. Then go to Q2, make this Y, go to Q2 and move left. Okay, move till you get a X. ये step wise पूरा example solve करना है. So for that, in Turing machine, it is better you take a small example. In other machines, you have to take a larger examples. In finite automata, you cannot take just 2-bit, 3-bit. You have to take 4 5 bits even in PDA. But in Turing machine, you can take a Smaller example, 2 zeros followed by 2 ones. That is enough. Is the example clear, students? Is this 0 raised to n, 1 raised to n clear? Any doubt in this? Students, any doubt in this? Students, any doubt in this? Any one of you? No? Shall we move on to the next example then? As I said, no, Yashasri. Only one example is more than enough. You just solve that example in detail. That's all. Two example is not required. Two example is required only in finite automata. Don't go for two examples for any other machines. Okay? One example is enough. Okay, so we'll move on to the next example. If you have any doubt in the previous example, let me know now itself, please, students. Since we have many examples that we have to look into, I'll just take the example quickly. Okay, Turing machine, design Turing machine to check whether the string ends with 110. Quickly tell me what will be the logic. Quickly. I am expecting some few answers. See, remember Turing machine has a head which can move in any direction. Okay, keeping that in mind, you have to frame the logic. तो अभी मुझे लास्ट में 110 चाहिए. तो what should be the logic? You can unmute yourself and give the answer if you are lazy to type. Or even you can type, no issue. Or you can give me the answer. Unmute yourself and give the answer. I hope you people are typing. I'm waiting. Students, I'm waiting for the logic. Even if you have wrong logic, let me know. Please. See, I have a string. ठीक है, मेरे पास string है और यहाँ I just it consists of zeros and ones. At last, it should have 110. What may be the logic for this example? मुझे find out करना है कि ये 110 है. What is the logic? It is very simple. Move right till we get blank. Yash says move right till we get blank and then move 3 bit left and check for 1 and then move right, check for 1, again move right, check for 0. Yes, very good. Any other logic? Any other logic, students? Ends with 110. I read again what Yash says. Move right till we get a blank and then move 3 bit left and check for 1 and then move right, check for 1, again move right, check for 0. What Preeti says it can check reverse 2 like 0, then 1, then 1. Okay, Preeti, very good. Yes, both the logics are right. You can go for any. Okay, but the simpler one is what Preeti says. We can either move left after blank and check 0, 1, 1. Yashasri, right? That's what Preeti also says the same thing. Okay, start from this. ठीक है, move right, fine. ओके, जीरो मिला उसको वैसे ही रखो, जीरो मिला उसको वैसे ही रखो, वन मिला कीप इट एज इट इज, वन मिला कीप इट एज इट इज, जीरो मिला कीप इट एज इट इज, till you get a blank, and just move right till you get a blank. If you get a blank, move left. If you get a zero, move left. If you get a 1, move left. If you get a 1, accept. That's all. Okay, we'll quickly draw this. How to draw this? This is your start state, right? Whatever we get, okay, if I get a 0, keep that 0 as it is and move right. है ना? If I get a 1, keep it as it is and move right. सब कुछ वैसा ही रखना है. Keep all zeros and ones as it is and just move right till you get a blank. If I get a blank, what I have to do? Keep it as it is and move left. Right? Okay? Then it is Q1. Okay, if I get a blank, keep it as it is and move left. What should I get? I should get a 0. है ना? I should get a 0. I should get a 0. Keep that 0 as it is and move left. खत्म. Move left. क्या मिलना चाहिए? Yes, we should get a 1. Keep it as it is. Move left. फिर यहाँ पे what should we get here? We should get a 1. Keep it as it is. What is the operation if I get a 1 here? What is the operation I should do? No operation. Very good. No operation. Done. ये अपना फाइनल स्टेट Q4 लिख सकते हो या QF लिख सकते हो. This is your final state. Simple.